we started talking about FSPro back in the early mid-2000s, and at that time the realization in the fire behavior community, fire behavior analysts, is that we needed to consider more the uncertainty in fire behavior forecasts, and to also combine that uncertainty with the values at risk. Because actually it's not the fire that really we care about so much, it's what the fire does. And so what we thought was an improvement was to try to provide a risk-based analysis system to where you're estimating probabilities of fire impact and then overlay that with the values at risk. And so we already had a system in the US called RERAP. It was a rare event risk assessment process that tried to provide probabilistic estimates of fire impacts. But that was a one-dimensional calculation, and since fire doesn't spread as a one-dimensional process, a better way to do it is in a two-dimensional fire growth modeling framework, taking into account the spatial variation in topography and fuels and weather. In order to come up with probabilities of impact, what we need to do is vary the climatology, vary the weather. And that's one of the most uncertain factors with fire behavior is the weather. Beyond some forecast period, whatever that might be, 1 day, 2 day, 3 day, or a week. Beyond that, essentially you are relying on climatology in order to make your predictions. What could happen in this area? And so the way to get probabilistic estimates of fire impact is to create what's called an ensemble simulation. You simulate thousands or tens of thousands of runs, each with a slightly varying weather sequence, and you take a look at the probability field that results from the fire growth under all those different sequences of weather. And the idea then is that you have probability of impact within a certain time frame, say 10 days or 14 days or something, and you overlay that with values at risk. Whatever values you're concerned about, whether it's developed infrastructure or habitat, watershed values. The whole point of FSPro is to allow variability in climatology to be portrayed in the fire behavior simulations, all developed within an environment when we were thinking that if only we could estimate risk, and risk being the probability times the consequence, if only we could estimate that and display that and understand it, then we'd be able to see that many of these fires, or parts of many fires, actually don't present any kind of risk to things that we care about. And that we thought, given the fire use modules, that this would be an excellent tool to be able to justify alternative management strategies for large fires. And when used in that way, it allows you to see a variety of different options for managing a fire. And unless you have some specific information, such as a weather forecast, and maybe the weather forecast is for some kind of extreme event, then FSPro is probably not the model to choose, right? FSPro is going to give you probabilities of impact. It's not going to give you a specific example of what could happen if you know specifically the scenario you're interested in. And so you'd have to go back to one of the other models that gives you the ability to dial in some very specific conditions and then play out. So with a near-term simulation, for example, you can put in highly specific weather and wind changes and play out different specific scenarios. What happens if the wind comes out of the west at 30 miles an hour? What happens if we get a cold front? What happens if we have a persistent scenario, high pressure stays in here for a long time and it lasts for 2 weeks? Those are different questions, and you need a different model or a different kind of analysis to deal with it.